We should consider a firm whose production technology is described by the following table. So here we have, to simplify our discussion, we always consider two factors of production, capital and labor. And here we also have machines, it's capital, and workers, it's labor. Let's write down 0 machines, 1 machine, and here workers. So here will be capital, here labor. When we don't have workers, machines cannot produce anything without workers. So in the table, when we fill in it, here will be the production. How many units of good we produced by using such amount of factors. So here 20, 30, 39, 46, here. So, okay. First question. Can we observe the law of diminishing marginal returns with respect to labor? Let's write down. Law of diminishing marginal returns. With respect to labor. Who can explain what that means? Maxim, please.
Okay, so basically, the following law, it explains how workers, and in our case also the machines, they correspond with the efficiency of the labor. And basically, at some point, it keeps growing because we get more workers, more machines, and it keeps growing. But of course, it grows always in a different way. So, for example, we can see that after we have, for example, 0 machines, and we got we got 1 worker. But when we got 2 workers, they did not produce 40; they produced 35. And after we got a 3rd worker, the production did not double as we could have expected. It keeps growing, but it's not stable. And the same with having machines. And at some point, well, we don't have this point in this table, their efficiency will start declining as soon as the number of workers will be too large. So the company will not be effective. So yeah, this law of diminishing marginal returns can be applied here.
Yes, thank you. So let's write down. In general, first of all, law of diminishing marginal returns here with respect to labor, what that means in our terms. It means that when the number of workers increases, each additional worker, it produces for us less than previous one. Yes, that means that marginal product of labor, by definition, it is the change in total product with the change of workers. Marginal product of labor decreases. Yes, this is the law of diminishing marginal returns. One more time. What means marginal product of labor? It is how much the last additional worker produced for us. Okay, how much this last additional worker added to our production, how many units it produced. So let's count for each number of workers. Let's count this marginal product of labor. So here we will have marginal product of labor from the first worker, here marginal product of labor from the second worker, and here marginal product of labor from the third worker. How we should count it? We should fix the capital, and to see how much each additional worker added. So when we have 0 machines, when we did not have workers, they produced nothing. And one additional worker, one more worker produced for us 20. So marginal product of labor from this additional worker is 20. Yes, the change in production, 20. Then the second, when we have 2 workers, we have production total amount 35 units. So the second additional worker, how much he added?
15.
Please.
15.
15, yes, it's the change. So 35 minus 20, it's 15. And the third additional worker, how much he added?
Only 13.
13, yes. And you see, when we have 0 machines, we have a low diminished marginal returns. Yes, marginal product of labor decreases with the amount of workers increasing. So fix 1 machine, 0 workers, 0 units, I don't know, 0 bananas, 1 worker, 30. So marginal product of labor from 1 worker is 30. Then here, what we have to write? Second
We
worker,
the 20.
20, yes.
23 here, yes, and here
20, just 20.
20, yes. Also diminishing returns. And let's
39,
write down 39 here. How much?
28, 28,
8 and
26.
26. Same, yes, and decreasing. Here 46.
46, 34,
8 minus 46, 44, or
34, 34,
34, and here
31.
31. Yes, awesome.
Quick maths.
We fix capital. We see when we fix capital, for each amount of capital, each additional worker produces for us less than previous one. Add to our production less than previous one. That means that law of diminishing marginal returns works here. Yes. Please, questions? Should I repeat to Russian this one? No? Okay, I hope. For you, for your homework, you can count the same about marginal product of capital. And check the law of diminishing marginal returns about capital. It's for homework. So how you will count? You will fix the number of workers and see what's happening when we add additional machine. Okay, then next. Characterize the type of returns to scale for this technology. Our new thing, returns to scale. Who can explain what that means? What means returns to scale? Anastasia, please.
Well, return to scale is like whenever a firm increases the inputs, like all inputs which it has, it uses some factors of like labor, capital, which we have, and these factors result in the scale, how like it returns to scale of the function. For example, if the like lambda is, that's right to say, like lambda, capital lambda labor is equal to lambda f of capital and labor, it means that like constant return to scale, for example, and so on. It could increase or decrease.
Mm-hmm. Yes. So if it's difficult for you for first moments to think in terms of lambda, you can think like this. So I have some production function. I produce something using labor and capital. Yes. And if I will increase labor and capital 2 times, and if my production, if the amount that I produce increases by more than 2 times, I have increased returns to scale of my production. If I will increase labor and capital 2 times at the same time, 2 times, and my production will increase also 2 times, I have constant returns to scale, and vice versa, decrease returns to scale. So in general, let's write down. So we have some production function quantity that we produce, which depends on labor and capital that we use, this production function. Or you can write F here, no mind. And if we increase labor and capital in lambda times, where lambda is some constant greater than 0, so we increase, not decrease, yes? And our new amount that we produced is greater than lambda of previous production, that means that we have increased returns to scale. Increase in returns to scale. If we produced less than lambda multiplied by the previous amount, we have decreased in returns to scale. And if we double, for example, double our labor and capital, and our amount produced doubled, so we have constant returns to scale, constant returns to scale. So here, what points we should take? So before we had, I don't know, 1 worker, 1 machine, yes, this one, we produced this amount, then we, for example, doubled, yes, amount of resources. So we should take 2 machines and 2 workers, this one we produced. And then, for example, triple, 3 machines and 3 workers, this one. Yes, and let's check. So, quantity that we produce when labor equals to 1 and capital equals to 1 is how much? 30 units of production. Yes, then when we doubled, so lambda is equal to 2. Yes, when we doubled labor and capital, we produced 67. With what conclusion we can make? Mr. Sear, can you continue?
Yes, so it should be constant, or no, it is increasing, increasing, returning to scale. Yes.
Yes, because we compare 67 is greater than 2 multiplied by this quantity when we use only 1 labor and 1 capital. Yes, it's 2 multiplied by 30, 60. So this situation. Yes, but then let's continue. Maybe it's not always in our table increasing returns to scale, because scale can change. So if we have 3 workers and 3 machines, we will produce 111. With what we should compare? Maxim, please.
Yeah, so we should compare with 67 maybe.
But we, what we did, we multiply labor and capital by 3.
Yeah.
So lambda will be equal to 3. If you will compare with 2, lambda will be equal to how much? 3 over 2. Yes?
Yeah.
Okay. We can. So it's greater than 3 over 2 when quantity were equal to labor were equal to 2 and capital equals to 2. And this is, let's count, 3 over 2 multiplied by 67. I don't know how much is it. approximately? Who can count?
I guess it's 100.5.
100,
100.5.
like this, yes?
Yes.
Ah. Yes. Okay, so yes, it's exactly greater than 100.5. So, okay, in each case, we have increased returns to scale. Yes. So, conclusion.
Excuse me, why is it 3/2 that we're multiplying?
So, if we will compare with the previous quantity, when labor equals to 2, capital equals to 2, then we make labor equals to 3, capital equals to 3. So we multiplied lambda is equal to what? From 2 equals to multiplied by lambda by 3/2. It's lambda equals to 3. Yes. So we should multiply here to make 2 times bigger, 3 times bigger, 3/2 times bigger. Okay. But also we can compare with 1/1. Yes, with 1/1 it's simpler because lambda is equal to 3. If we compare with 1/1, it is definitely 111 greater than 3 multiplied by 30. Yes, 90. Same. And 30 was what? 30 was quantity when labor equals to 1, capital equals to 1. You can compare like this. So this will be a lambda. And here, if we compare with 2, 2, this lambda. Okay?
Yeah, thank you.
So let's move on, or please ask questions right now about this task. In the second task, we continue to speak about returns to scale. And in the second task, we have not table, but function. And with function, it's easier to check, I think. First production function. Capital multiplied by labor. What returns to scale we have? Ulyssey, please.
I think it would be the constant, because if we multiply the Q by 2, we have this rises capital and labor. This, I guess, so
Constant.
constant returns to scale, I guess.
Anastasia.
I'm not sure because I think we have increased because, for example, if we add a 2 as the how it says like the
If we make labor and capital 2 times bigger, if we
Yes,
double.
I mean so it would be like 2 in front of the Q, but 4 in front of the capital and labor, because we should multiply and capital and labor on into like 2 times. It means
Yes.
they would be 4 times bigger.
Yes, exactly. So let's check in general for lambda greater than 1. If we make capital and labor lambda times bigger, what that means? Instead of capital, we should write lambda capital. Yes, instead of labor, we should write lambda labor. So open the brackets, it will be lambda square capital multiplied by labor and labor. And this is previous quantity. Yes, and then this is the production that we have right now. We should compare it with lambda Q. And we see that lambda square, if it is greater than 1, and it's greater than 1 because we increase the amount of resources is greater, so we make the conclusion that it's increasing returns to scale. Ulyssey, did you get it? Okay, you understood?
Yes, understood. Yes, understood.
Okay. So next, number 2. It's square root out of capital plus square root out of labor. Who wants? Ulyssey, next try.
Yes,
Please.
next try. I guess, I hope so. It is decreasing because when we yes, if we took the quantity,
Mhm.
because the square root even multiplied will be less than the quantity. Yes.
Mhm.
Square root should I mean should not be here anymore, because if we do mathematically, like square root would just flow away from here. If we, for example, like paste 2 as we did previously, the square root would
It will be square root square root multiplied by quantity, previous quantity.
yeah, but I mean like 2q, it will be equal to 2 square roots of capital plus 2 square roots of labor, and we can do as like okay, never mind, but like it just math.
Yes, we put the square root out of 2, out of lambda, out of brackets, yes? So this will be square root out of capital plus square root out of L, and this is our previous quantity. And when we compare square root out of lambda with lambda quantity, it's less. Yes, so we have decreased returns to scale. So our production increased by less than 2 times if we double our labor and capital. Good. So it's decreased returns to scale. And third in 2/3. Here, Maxim, please.
Yeah, as I understood, it's quite similar to the first function, but this time it will still increase, but with lower temps are
Yeah.
lower and
It would be
slower.
yeah.
Exactly.
Increase returns to scale. Let's check how returns to scale depends on this function in general. It's Cobb-Douglas function.
Yeah.
The favorite function of economists because it's easy to calculate and it explains a lot for us. So it will be quantity equals to capital in, for example, alpha multiplied by labor in beta, where alpha and beta, they are degrees, yes, and they are greater than 0. And let's check for this in general returns to scale. So what we do, as always, we multiply labor by lambda and capital by lambda. So instead of L, we write lambda L. Instead of K, we write lambda K. So lambda K, everything in alpha, multiplied by lambda L, everything in beta. So open the brackets, what we will have? Lambda alpha multiplied by lambda in beta, K in alpha multiplied by L in beta. So this is the previous quantity. Agree? And here we have what? Lambda in what degree? Alpha plus beta. Yes, multiplied by quantity. And we should compare it with lambda multiplied by quantity. So we should compare it. How to see? How we should compare. So returns to scale, you see, it depends only on degree of the sum of this alpha and beta. Yes, and the sum. Here we have lambda in degree 1, and here we have in alpha plus beta. So what conclusion we make for Cobb-Douglas function? If alpha plus beta greater than 1, what returns to scale? Which returns to scale? This will be bigger than lambda. You don't see, yes? Okay.
No, sorry, I was just trying to. Okay. Fine.
What I did wrong. So one more time, I will rewrite. So we have lambda in alpha plus beta multiplied by quantity, and we should compare it with lambda multiplied by quantity. So what we should compare? These are the same, only degrees are not the same. So we should compare alpha plus beta with 1. Yes?
Oh, you said if alpha plus beta greater than 0, you asked what should, yes?
Greater than 1. Greater than 1.
It should be like increasing.
Increasing returns to scale, yes. If less than 1,
it's decreasing returns to scale.
and if equals to 1, constant, yes? Yes. So let's check. I will give you examples. If we have such function, k in 1/2 multiplied by L in 1/2, what returns to scale has such function?
It's constant.
Constant, because you sum up 1/2 plus 1/2 is 1. So constant returns to scale. It's for the pace of your solving. Yes, you look at the function and you understand returns to scale. If you will have, k in 3/2 multiplied by L in 3/3. No, multiplied by 3/4. What returns to scale? Easier. Increase, yes, because 3/2 it's 1.5, and we sum up it with something positive also. So 3/2 plus 3/4 greater than 1. So increase in returns to scale. Increase in returns to scale. Here constant returns to scale because 1/2 plus 1/2 is 1, and decreasing. Let's say k in 1/3 multiplied by L in 1/3. 1/3 plus 1/3, 2/3 less than 1, so decrease returns to scale. Okay, so we proved it in general. Should I repeat something, please? Okay, so let's move on. Our next task is for you from the lecture. It's like question from the quiz. Not from yours, but I think it's a typical question from the quiz, number 3. In the long run, if a firm truly minimizes its costs, so we minimize costs, the quantities of inputs it uses should be chosen in such a way that marginal productivities of the last unit of every input, its marginal product of labor and marginal product of capital, divided by that input's prices are the same. Why does this principle make sense? So let's write down in our terms. So marginal product of labor over the price of labor. What? How to name the price of labor? What we pay to workers?
Wage.
Wages.
Yes, so here will be wage. Should be equal to marginal product of capital over the price of capital. How we name the price of capital?
Revenue? No, not revenue.
Yes, it's R, but it's interest rate. It's rate. Why it's the price of capital? Because always we rent something. We rent machines. We rent apartments, offices, or something like that. Yes, and buildings and machines. That is capital. So interest rate is the price of capital. So why this is the condition for cost minimization? Maxim wanted, no?
Cost minimization, we talked about it.
Why this is the condition of cost minimization?
Cool.
Okay.
Maybe
Okay.
because We find the optimal equilibrium of wages and inputs and to the capital, and we try to minimize everything, maybe like that.
So from here, from this condition, we will find how many workers should work in our firm and how many machines we should rent. Yes, the amount, please.
Excuse me, could you please explain once more this equation? Like, what did you mean by that? I just don't understand it.
That was my question for you, because I wrote down what is written. I wrote down what is written in the task. Marginal productivity, so the last unit of every input, divided by that input's prices are the same. Marginal product of labor over the price of labor should be equal to marginal product of capital over the price of capital. And the question is why it is so. Please?
I understood.
May I try?
Yeah, okay.
Okay, actually, if I'm not mistaken, actually it is like a law, not a law, but like the rule of the minimal costs, which exists in economy, and it just worked like this. But actually, so the firm, in any cases, like to use how to say, to maximize its output, it should use additional units of any resource, like, I mean, to maximize profit, as long as each subsequent unit of this resource gives a greater increase in total income, in total total income. So of the firm, compared to the increase in how it costs, how it's gross, not gross costs, but I forgot in English how it says.
Marginal total costs.
All of these, yeah.
Total costs.
Total costs, yes. So then the condition for like maximizing profit is the use of such in amount of the resources that the marginal product in monetary terms will be equal to the marginal costs of the resource. So it's just the thing which you wrote.
Okay. I will explain, because I don't think it's too easier for you to explain it for all of us. So I will give you an example. What means, one more time, what means, for example, marginal product of labor? It's how our quantity produced changes when we change the amount of workers. How much additional worker add to our production. So let's say last worker in our example, last hired worker produced for us 5 additional bananas. And we paid to him the wage, $2. $2 wage. It's last hired worker. He produced additional 5 bananas, and we paid to him $2. This is how much? 2.5 bananas per dollar. Yes. And last additional machine produced for us 6 bananas, increased our production by 6, and we paid for its rent, I don't know, $3. And this will be 2 bananas per dollar. In this situation, please compare and tell me the conclusion, what we want to do. What we want to do in this situation.
Hire more workers.
Yes, you see this? Because workers now are more productive. So they give us more. They give us more by dollar that we spend on them than last machine. Yes. So here will be 2.5 bananas per dollar spent. Yes, is greater than 2 bananas per dollar spent. So we want to hire more workers. Hire more workers. But let's remember that we have law of diminished marginal returns for each factor. So let's hire one more worker. Hire one more worker. And this next worker will produce for us not 5 bananas, but less, because we have law of diminishing marginal returns. Yes, he will produce for us, for example, 4 bananas, because of law of diminishing marginal returns. 4 bananas, and we pay to him same wage, because wage is constant. Yes, wage is constant, same wage, $2. It's 2 bananas per dollar. And we compare with the same about capital, because capital we did not change, so it's the same 2 bananas per dollar. And now here is equality, and we stop here. We don't now in this situation we do not want to change the amount of workers or the amount of machines. Yes. In this situation also, one more time, here we had 2.5 bananas per dollar. Here we had 2 bananas per dollar about capital. Also, second, what we can do, not hire more workers, but to sell machine. Sell one machine. If we will sell one machine, due to law of diminishing marginal returns, marginal product of capital will increase. Yes, when we sell one machine, here will be how much, for example, to have 2.5 or 7.5 bananas. Yes, last machine will produce for us, and here will be also equality. Okay, in general, this situation, this was so when we have here equality, so we stop and have some workers and amount of capital. That will not change. That's why I write here stars equilibrium. Yes. So we stop here. So let's say in general that, for example, marginal product of labor now is greater than marginal over wage is greater than marginal product of capital over interest rate. What we want to do, as you have said, we want, in this situation, we want to hire more workers. But when we hire more workers, that means that marginal product of labor decreases due to law of diminishing marginal returns. Yes? And let's see, marginal product of labor decreases. And here, up to the point when we have, once again, equality. Yes? When marginal product of labor over wage should be equal to marginal product of capital over rate. Vice versa. If we have now less marginal product of capital over rate. If we now have less, what we want to do in this situation?
We will increase the amount of capital.
Yes, we want to increase the amount of capital, and when we increase the amount of capital, each additional machine will produce for us less than the previous one. Yes, something positive but less. So marginal product of capital will decrease, and if it decreases here, decreases up to the point when here will be the equality. Yes, units per dollar spent from our side should be equal, such that we will minimize our costs. Okay? Please. Should I repeat it in Russian? Guys?
Yes, please.
Yes, please.
Окей. Так, ну смотрите, давайте еще раз. У нас какая здесь ситуация? Нас спрашивают, почему предельный продукт труда, да, разделить на заработную плату равен предельному продукту капитала разделить на ставку процента. Да, мы платим нашим работникам зарплату за капитал, за всякие машины, мы их арендуем, поэтому у нас здесь ставка процента – это цена капитала. Вот, да, ну и смотрим. Я могу еще, смотрите, как объяснить. Вот в чем считается предельный продукт труда? Ну, в бананах, да, в каких-то единицах, да, вот что мы там производим в итоге. Если умножить предельный продукт труда, например, на цену конечной продукции, это что получается? Вот предельный продукт труда – это сколько нам последний нанятый рабочий произвел бананов. А если умножить на цену этих бананов, это сколько нам последний нанятый рабочий принес бабок. Нам в карман. Правильно? Вот. Да, и значит, если цену, да, конечную продукцию умножить на предельный продукт капитала, это сколько последняя машина, да, которая у нас там что-то производит, сколько она нам бабок принесла, да, на нашей фирме. Вот. И смотрите, если это разделить на то, сколько мы потратили на найм этого последнего работника, да, а здесь сколько мы потратили на аренду последней машины, это должно быть здесь должно быть равенство. Что получается? Сверху у нас числители, сколько денег нам приносит последний нанятый рабочий, да? Снизу сколько мы на него тратим денег. Ему же зарплату надо платить, это нам в минус идет, да, в нашей прибыли. Вот. Да, и это должно все сравняться. Если это не равно, что происходит? Вот если здесь больше, это что означает? Что труд, последний нанятый рабочий сейчас нам приносит денег больше, да, за доллар на него потраченный, да, если считать. Денег нам приносит больше, чем последняя машина. Значит, мы что хотим в этой ситуации делать? Мы хотим, нам это нравится, да, то, что работники лучше сейчас работают. Да, если разговаривать в терминах долларов на них потраченных. Вот. Мы хотим больше работников нанимать. Но мы с вами знаем, что если первый там нанятый Петя нам сделал, там, не знаю, сорвал 6 бананов, то второй нанятый Ваня, он нам сорвет дополнительных 4 только банана. У нас вот это вот закон, убывающий предельной продуктивности. Да, вот это low diminishing marginal returns. Да, и значит, вот если мы еще одного наймем, то он нам произведет не столько же, сколько Петя производил. Да, и следующий нанятый Вася, он нам денег принесет меньше, чем предыдущий. Да, и мы так будем нанимать, пока снова не станет равенства. Вот. Мне кажется, вот так, мне кажется, попонятнее именно вот в деньгах, ну вот в терминах денег. Да, потому что тут теперь и тут в долларах, да, и в знаменателе в долларах. И вот эти соотношения, должно быть равенство. Да? Когда равенство? Что такое равновесие? Да? Это ситуация, когда мы не хотим ничего менять. Все, мы остановились. Вот когда тут равенство, мы не хотим ничего менять. Вот, такие дела. Так, попонятнее?
Да.
Ну ладно, давайте. Все, дальше. Угу. Okay. First of all, in problem 4, we will speak about costs. But first of all, let's write down everything about costs for you. So costs, it's how much we spend for producing product. Yes, how much the firm spends on producing product. So first of all, we write down total costs. It's all costs that a firm has. We can divide these total costs on what? On variable costs and fixed costs. Fixed costs is what? They does not depend on how much we produce.
Yes.
Yes, for
Like
example,
the wage of the management of the company.
Authority.
yes,
Authorities.
yes, wage of management, rent, rent of office, yes, something like that. It does not depend on how much bananas we produce. Then variable costs, by definition, they vary, yes, according to the quantity we produce. So, okay. Then next, average costs. Average cost, how to count? How much on average we spend on each unit we produce? It's total costs over quantity that we produce. Yes? How much we spend on production of one banana in average? We can divide it also on average variable costs and average fixed costs. This is variable costs over quantity. This is fixed costs over quantity. This was average costs. And the last, yes, the favorite costs of economists, marginal costs. Marginal costs is what? How much we spend on additional unit produced. Yes, and last additional unit produced. So by definition, it's the change in our total costs when we change the quantity that we produce. Yes. So it's total cost when we produce, for example, Q2 minus total cost when we produce Q1 divided by the change in quantity, Q2 minus Q1. Let's write. So here, total costs consists of variable and fixed costs. Yes. So this will be variable costs when we produce Q2 plus fixed costs when we produce Q2 minus variable costs when we produce Q1 minus fixed costs when we produce Q1 over the change in quantity, Q2 minus Q1. What I can delete here? What is the same? What does not change?
I guess it's
Fixed.
fixed costs.
Fixed costs, yes, because they does not depend on quantity. They are fixed. They are the same whenever we what amount we produce. Yes. So fixed costs, it's constant. We delete them. And here what we have, it is the change in variable costs over the change in quantity. So marginal cost is the change in variable costs. Yes, when we produce the last additional unit. And if we will take these changes, very, very small, and take the limit, by definition, it's the definition of a derivative. So this will be total costs prime, the derivative from total costs, and the derivative from variable costs. You can count like this or like this if you have functions. This for functions. You use this formula. If you have table, you use this formula. Yes, with changes, with deltas.
Can I ask you a question?
Mm-hmm.
But actually, how can we like say but because these formulas, we have different formulas for long run, short run, or мгновенный период. I don't know how it's in English. So
Long run. No, we have the same. We have same formulas, but in long run we don't have fixed costs. Yes, fixed costs, they are equal to 0, and that's all.
okay, so we suppose
run.
we have short run.
Yes, we have fixed costs only in the short run, because by the definition of long run and short run is the situation when we can change all resources that we have. So all our costs will be variable. Yes, and in the short run we have too little time to change the amount of all our resources, and we can say, for example, that in the short run we have too little time to change documents for renting the building. Yes, so we if we do not produce anything, we should pay for the rent of the building in the short run. Yes, it's our fixed cost. And in long run, we can change our capital and labor, so we will not have fixed costs. Good question, thank you. Here's 60, then here 44, here 72. Okay, who wants to start? Only Nastya? Okay, Nastya, please.
So first of all, the easiest thing which we can like do here, it's our average costs, because we have total costs and we have Q. So average costs for the first, I don't know, road would be 60 over 0, and it would be 60.
No, 60 over 0 is not 60.
Oh, it's 0, obviously.
Not 0.
Why we cannot? It's nothing. I mean,
it's plus infinity. Yes, when we divide on something very, very small, it's plus infinity.
Plus infinity. Then
yes,
we also have a total cost for the third, the 1 to the.
I ask about the first row, only the first row. Okay. Please fill in the first row.
Then we probably can.
When we do not produce, when we produce nothing, variable cost equals to what?
0.
0, yes. We don't have variable cost because we did not start our production. So here will be 0. And we know that total cost consists of variable costs plus fixed costs. Yes? And if total costs are equal to 60, so fixed costs are equal to 60 because we don't have variable costs. Then we do not count here marginal costs. Why? Because marginal costs, we need the change in quantity, but we did not start the production, so it's not 0, it's nothing. Marginal costs are nothing when quantity is equal to 0. Then average fixed costs also is fixed costs over the quantity plus infinity. And average variable costs 0 because we did not start our production. So, okay. Ivan wanted to fill in this second row, I think.
Yeah, maybe. We can find total costs. It's 104.
Yes, how we counted it. So
we add MC, yeah, to the first total cost. Then
104 then.
Yeah, FC, so also 60.
We can fill in here everywhere 60 because they are fixed. Then variable.
This is 44. Average cost will be 104.
104. Okay, so 1, yes. Average
yes. And then here we got 60 and then 44 also in variable, average variable costs.
Yes, because we divide over 4 or over 1 everywhere here. Yes, thank you. Who wants to fill the second row? Елисей, please.
Yes, the total cost would be, as I understand, 104 because we multiply average cost by 2 and summarizing with fixed cost. Yes, yes, it's wait. No. 144 plus 60 is 204. It's total cost. The
144. It's total cost. We have fixed cost.
Oh yeah. Understood.
It's
Yes.
the part. It's the part of
Yes,
total.
the variable
So
cost is it's
how much?
84.
84. Yes. So 84 plus 60 is total cost 144. Yes. Then marginal cost.
Then it's yes, it's 40. No, it's 42.
No. It's the change in total cost when we change the quantity. The quantity change right now is 1. Yes. So we produced 1. Now we produce 2. The change in quantity is 1. So by
Yes, it's 40.
40. We had 104. Now we have 144. So the change in costs is 40.
It's 40.
Average fixed easy 60 over 2. Yes. Average variable easy variable over 2. Okay. So third row, who wants? Somebody else? I asked you. Okay. Елизавета, please.
Okay, so we have total cost and fixed cost. Then variable cost is 96.
How much? 96. Yes, 96.
Yeah.
Then
marginal cost is how do we count it? Is it total cost in 3 minus total cost in 2?
It's the change in costs when we change quantity. We change quantity by 1, so is the difference between 156 and 144.
Yeah, then it is 12.
12, yes.
Then average cost is 156 divided by 3. And I 50 plus 2, 52.
Yes. Okay. Let's not count this because it's easier. Thank you.
Okay.
Here 96 over 3 because that's all average. One moment. We can count marginal costs, as I have told you. We can count marginal costs by the change in total costs or by the change in variable costs. Yes? You can see, for example, variable cost before we had 84, now we have 96. The change is 12, the same change because fixed costs, they are fixed. Yes? You understood?
Yeah.
So, and last row, Diane, please finish.
Okay, so let's see. The first one is gonna be 182 minus 60, and it's going to be 122, if I'm right. Yes. Then the next one is going to be marginal is 182 minus 156, so it's going to be, let me count quickly, 26. Then it's going to be, the next one is going to be 182 divided by 3, which is 60.6. Yeah.
Okay.
Then the is going to be, let's see. It's going to be 60 divided by, yeah, you already wrote it, divided by 4. And the last one is going to be 122 divided by 3, which is 40.6 approximately.
Divided by 4. Yes.
Yes, by 4. Oh, I say 3. Yes, divided by 4. Of course, it's the number.
Yes. Yes.
So yeah, that's it.
And also we can count marginal costs by the change in variable. You see, 96 was before, now 122. The change is 26, same change. Okay. So, okay, we stop here. We will start from the last problem in the next class. Guys, please, questions, comments, something, tell me. Okay, yeah, thank you so much. Please be prepared for each class, read the textbook, something like that, and read problems that we will do, okay, before the class. So see you next Thursday.
Thank you so much. Have a nice day.
Thank you. Goodbye.
Thank you. Thank
Bye.
you. Goodbye.
Bye.